Hello all. Thank you all for listening. I'm Shermayne Lee. I'm a DevOps consultant at Mechanical Role. Today I'm going to tell you a story about Internet of Dog. It's basically a story that I combine internet and dog together and make them smart. But I'm not building a robot dog. So I have a dog. I love my dog. For people who have dog, you probably have the habit of walking your dog just about every day. I'm the same. I have to walk him twice a day. So, and it's coming to talking to the people in the park. I'm usually the shy one, and luckily I've got him. He usually does all the ice breaking for me, which is great. However, I've got a problem with that though. With him being so friendly, he tends to run away from me. It runs to anyone, any dog in the park. Forgot to mention, he is small, but he's really quick. Most of the time, I have difficulties looking at where he has gone. I really hate myself chasing after him. Therefore, there's one day I was so mad. I was thinking, can I do something about it? Can I build a simple GPS tracking application that tracks his movement? People might ask, there's so many tracking devices available in the market. You can easily buy one and put it on your pet. I did some research for those. Most of them are out of my budget, and also I have very limited control on the data from the device. So I started to think, why not build my own GPS tracking application? It's gonna be fun, and I can learn while I was building it. So I'm gonna tell you how easy to start an IoT project and apply to your daily life. Before I start the project, I definitely face few challenges. I know before I can start writing the spicy coding bit, I need the parts and put the physical tracking device together. So I started to research all the parts in the market. So the more I look at it, the more confused I get, not even saying that I haven't decided how I want to get the device connected to the network, either via Wi-Fi, either via mobile phone. Even better, can I send it to the cloud? I'm looking for a solution that is simple and easy to start. Is that even possible? So I found myself a working solution here, which is great. So this is a architecture diagram for my mini project. I've got a tracking device that will get connected to the server via the gateway. So it is a server in the cloud, which is awesome because they have integration with AWS. So that's the biggest selling point where I use the server so that I can get the data pulled from the server to the AWS, and I can do so much more when the data is in AWS. I have that integrate with AWS IoT and have the data stored into the table, into dynamodb, and I've got the React app, which will get the data from the table via Appsync. I'm gonna tell you every step in details on the next slide. First of all, I've got a physical device. It is a LoRawan device. So what is LoRawan? LoRawan is a wireless technology with long range and low power. It is like a Wi-Fi, but with longer range. It has a radius of 10 kilometer in radius. And it required really low power, so which is great for my use case, just because I can't put my dog near to a power port all the time, and I can't have a GPS tracking device that's running out of battery all the time. So now I've got an end device. The device will connect it to the server via gateway, and I can pretty much build an app with the data that I've got in the cloud. I was talking about all the gateways and server. So what is that? And I'll have to bring in the Thing network. And what is the Thing network? The Thing network is a global community build project with 150 countries, I believe. And at the moment, they have 15,000 gateways up and running. It is an open source project, so it is free to use. It is great for people who want to start an IoT project with LoRawan technology. Like even in Perth itself, it has 80 plus gateways up and running in a metro area. which is awesome. It works for the use case that I want. And it is very easy and straightforward to start. I'm going to show you how to start, how you can create your own little IoT project at home. So first of all, you need to create an account with the Thing network. It is free. Once you got that, you need to log into the console. You need to add an application and register a device within an application, and then select the data center that you want. And that's about it. That's all you need to get a device connected to the Thing network cloud. Here I've got a short video how you can connect your device to the Thing network cloud. Log into the console and navigate to the Add Application page where you need to configure your new app. You will need a unique app ID and you need the unique identifier for your app, choosing the right data center. Once you've got that, navigate to the Device tab where you can add a new device. Same thing. You need the new device ID, unique device ID, and then you need to have a device unique identifier for it. This is the important bit. The identifier is the ID that usually comes with the device. It's basically the ID is telling you what device you are registering to the Thing network. So once you got that correct, once you add the device, it's pretty much it. Now you've got the device that is connected to the Thing network. It depends on what device you have. You might have to decode the data. So in my use case, the data is coming in the format of 50 bytes. So I need to write a custom decode function in the format tab, so where I need to decode the incoming data to a more readable form. So once that's done, if you navigate to the Data tab, if you have a device that is successfully connected to the network, you will see incoming data in the format that you want. And this is the example on where this all the incoming data with the payload and the format that I have in the decoder function. And hooray, now I've got a device and I've got it connected to the network. So in the architecture diagram that I propose, I want to have that integrate with AWS. I'm going to tell you how you can easily do that. Before that, if you look at the overview page in the Thing network console, you can see on your configuration, there are two types of messages coming from LoRawan. It has uplink messages and downlink messages. Uplink messages is a message coming from the device to the network. Downlink messages is a message from the network to the device. So for most LoRawan use case, all you need is uplink messages. Like my use case, all I need is the data coming from the sensor. I don't need to send anything to the sensor. So all I concern is the uplink messages. Now I have the device registered to the network. I know the data that I need, so I'm ready to get it connected to the world of AWS. So I'm gonna integrate with AWS IoT. How does that work? So the Thing network is publishing the uplink messages via MQTT. MQTT is a pub/sub messaging protocol. So it's basically publishing to the topic, and you can subscribe to the same topic to receive the data. So in the Thing network, they have the topic documented in a certain format. So I know all the data that I need is the data from uplink messages. So I will subscribe to uplink messages in AWS IoT. Then once you've got that, you can either store the messages in dynamodb using the rules, or either you can invoke a lambda actions. It depends on where you want your data to be. In my case, I have stored in dynamodb. I haven't mentioned the bits where how you can get them connected. So in this video here, I'm going to show you how you can get them integrate together from the Thing network to AWS. So in the Thing network, they have provided you a CloudFormation template. Prerequisite though, you need to have an AWS account. So if you have the account, you will have to navigate to the CloudFormation, and then you need to provide the template URL from the Thing network. Once you've done that, you will need to do some configuration. The most important bit is the app ID and the app access key, which is the ID and the key from the Thing network that you have done previously. This is the important bit where you're connecting them together, and then you need to do some configuration for Elastic Beanstalk and also AWS IoT. So once that's done, if you navigate to AWS IoT, you can see the thing that you all have registered in the Thing network. It is now synced to IoT. So you can either manage them in IoT or the Thing network. They're now synced and connected together. So if you navigate to the rule, this is where you can tell AWS IoT what you want to do with the data. In my case, I am selecting the attributes of the incoming data. I only need the time, the latitude, and the longitude, and it's coming from the topic, which I was talking about, the topic for uplink messages. And once I've got the rule, I need to tell IoT what is the action, either to invoke a lambda or either it's writing to the table. I want it to be in the dynamodb table, so I have an action to write it to the table. So once that's done, it's pretty much it. You have got the working connection between the Thing network and AWS IoT. So now every time you turn your device on, your data will automatically store to DynamoDB, which is awesome. So now I've got the data in DynamoDB. I have a React app, which is a map that's gonna tell me where my dog is. I am getting the data from DynamoDB via Appsync. So what is Appsync? Appsync is a fully managed service by AWS for developers who want to use GraphQL API. It is very easy to start. It is usually perfect for serverless implementation, and it connects to the data source seamlessly. It will combine all different data sources together for you. But in my case, I only have one data source for now, which is DynamoDB. The best bit for Appsync is you will get real-time updates from your device. So you wouldn't want to refresh your page all the time and waiting the data to coming in. So via using Appsync, you can pretty much get the instant data straight away from the table to the client via Appsync. So you will need to have the schema that match how you construct your data source. In my case, it is DynamoDB. So it is basically telling Appsync what is the type that you're expecting. In my case, I am querying the data via the ID and the time, which is also the partition key and the sort key for my table. So because I am querying the data based on the time, this is how I construct the data. For the real-time bit, I am subscribing to a mutation, which is basically the mutation that's adding an item to the table. So every time there's mutation happen, there's new item to the table, it will fire the query, and then it will get the latest data and showing it to the app, which is awesome. Now I have a full working flow all the way from the device and show it to the app. This is my app, and it's telling me where my dog is. So I'm querying based on the date. I'm telling the app what date that I want to see. Select the date, and then on the map, you can see there's a black dot on the map, which is the location of my dog. And you can see on the picture that's my dog wearing the tracker. Clearly, he isn't very happy about that, but that's fine. I only have him wear that when he's out. So now I've got the app. So every time when he's out and when I can't find him, I don't have to worry about it. I just have to turn on the app and check where he's at and drive my car to get him. Thank you. That's pretty much from me today. I hope my talk can help you to start an IoT project. And feel free to ask any question. Thank you.